All right, so let's look at this. Let's think about what we know, what we need, all that good kind of stuff. So it says that we have a cylindrical barrel. Now, hopefully you didn't just write down scribble so that I didn't yell at you today, that you actually listened, worked through it, because otherwise you're going to get way more out of it if you've actually tried to struggle through this yourself. So a cylindrical barrel with a diameter of 2 feet, so that's all labeled for me, contains collected rainwater as shown in the figure above. The water drains out through a valve, so it's leaving the cylindrical tank, not going in. At the bottom of the barrel, the rate of change in the height with respect to t, so here's my dHdt, and then it says h is measured in feet, and t is measured in seconds. And I circle those because I inevitably get down into the question, and then I have to go back and hunt for the units because I didn't find them somewhere. All right, and then it gives you the volume of a cylinder, right? A says find the rate of change of the volume of the water in the barrel with respect to time when the height of the water is 4 feet. Okay, so remember these rates of change? Says the rate of change of the volume. So I'm going to start A up here, just so I can scroll. I want dV dt. Okay, this is what I'm looking for. And volume is cubic units, so this would be feet cubed per second. Okay, that says dV dt, by the way, because I know it doesn't look that good. All right, so in order to figure that out, I have V. I'm going to need to take the derivative of that. Would you agree? Okay, so when I find dV dt, I'm taking the derivative of this formula here. I'm going to have to use what kind of rule? Product rule, right? So I'm going to let that pi get stuck to the r squared, and then it's the r squared times h. So the derivative of the derivative of pi r squared is 2 pi r dr dt times the second, which is h, plus the first, which is pi r squared, times the derivative of the second. The derivative of h is 1 dH dt. Okay. So in order for me to find dV dt, I have to be able to substitute in for all of that stuff, right? So that means I need dr dt. Okay. I need r. Okay. And I need dH dt. And I need h, right? So it says, find the rate of change of the volume of the water in the barrel with respect to time when the height of the water is 4 feet. So they're telling me h is 4 feet. And dH dt, do I know that? That's right here, right? And we know that h is 4. What's the square root of 4? 2, so it's this negative 1/10 times the square root of 4. So this is going to be 2 over 10, which is a negative 1/5. And then that's dH dt, that is feet per second. Yeah, that's fine. R, what is R? 1. Does R change? No, this is a cylindrical tank, so that radius is going to stay the same. If this was a cone, then it would be changing. R is just 1 foot, right? So what's dr dt? 0. Okay. All right, so now that I have all that, can I substitute it into this? We're going to talk about another way to look at this too, but why that might be a little dangerous sometimes. I'm going to move over here. So when I substitute this in, that means that dV dt is equal to 2 times pi times the radius, which is 1, times the height, which is, times dr dt, which is 0, times the height, which is 4, plus pi times 1 squared times dH dt, which is negative 1/5. Right? This 0 here, zeroes out that whole term. So we get that dv dt is equal to, well, 1 squared is 1, so it's really negative 1/5 pi, and that would be feet cubed per second. Or negative pi over 5, either way. So the scoring guidelines on this, so this is one of those where I had a question for Ms. Bruce because I was like, what? I thought I printed it out and bring it up here. But it gave you a point for taking the derivative, but like what it said a point for saying that dv dt equals, I don't remember exactly what it said. But, and I was like, well, I don't have that exact thing, but I had this, and it is equivalent because of whatnot. So if you took the derivative, you're good, and then your other point is for the correct answer with the units. Another way to look at this is this. If you know that the rate of change of r is 0, like r doesn't change. We have to have these dh dt's, dv dt's, because that changes over time. The radius never changes. Right here, we could have said, since r is 1 for the whole thing, then volume is really just pi times h. So then dv dt equals pi dh dt. That's what it said over there. And you could go that way. And that works. The problem is you might use that when you're not supposed to, because it's something that changes, so it's probably a little safer just to take the whole derivative. But you can't make up math when you do that. Okay, we good? Okay, so let's look at B. B says, when the height of the water is 3 feet, is the rate of change of the height of water with respect to time increasing or decreasing, and explain your reasoning. All right, so let's think about what they're asking us, what we know how to find, what we can do. So it says when the height of the water is 3 feet, is the rate of change of the height with respect to time increasing or decreasing? Okay, so the rate of change is the derivative, right? We want to know if it's increasing or decreasing. What do you look at to see if the rate of if the derivative is increasing or decreasing? The second derivative. Because if you do your little fun box, the unbox, yeah. And this is up, down, plus, minus, so that's f prime. So this is f double prime, this is plus, this is minus. So what it's asking me is the rate of change, this right here, increasing or decreasing? This is what this is, so I have to see if the second derivative is positive or negative. Okay, so for B, let's find the second derivative. Okay, and it says of the height, so let me write down what this is. dh dt is equal to negative 1/10. Since I'm rewriting this, I'm going to go ahead and write this as h to the 1/2 power, because I want it that way anyway, right? Okay. So do I separate the variables? Like, am I going to multiply both sides by dt? No, because I'm not trying to integrate that, right? I am going to take the derivative of both sides, so d dt, take the derivative of both sides. So that means that second derivative of h with respect to time, both times, is equal to, so I take 1/2 times negative 1/10, that becomes negative 1/20, right? Then I subtract 1 from the exponent, so this becomes h to the negative 1/2. And is that it? I mean, is that it right now? Good here. Okay. And then dh dt. Okay, we good? Am I done with my second derivative? No. We got to take this part, and put it in right there, right? So then that's going to give me the second derivative. Remember, getting these 2's in the right place are important. Okay, that is equal to negative 1/20. And can I just go ahead and put the square root of h in the denominator? Yes. Okay. Because when we actually substitute stuff in, we kind of rather that be in the denominator like that. And then dH dt, this is times negative 1/10 times the square root of h. Right? What happens with the square root of h? They cancel out, and this just equals 1 over 200. We agree with that? Okay, so we found the second derivative. Now we want to know when the height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing? And explain your reasoning. What is it? Increasing. Why? Because it's positive. Because the second derivative is positive for all of them, right? So we can say, so dh d2h dt squared equals 1 over 200 is greater than 0. Therefore, the rate of change, the rate of change of h is increasing at, or I guess when the height of the water is 3. Well, at h equals 3 is fine too. Yeah, I put dH dt as increasing when h equals 3 feet. Okay, make sense? Questions? Okay, let's look at C. So on C it says, at time t equals 0 seconds, the height of the water is 5 feet. Use separation of variables to find an expression for h in terms of t. Okay, so let me go down here. So let me rewrite this. So this is part C, and we have dH dt is equal to negative 1/10 times the square root of h. Right? And then the ordered pair was 0, 5? Yes. 0, 5. Okay. All right, so first thing I'm going to do is I'm going to multiply both sides by dt. So dH is equal to negative 1/10 times the square root of h times dt. Like you do them both in one step, that's fine. If it's a more complicated one, I would suggest maybe not, just so you don't accidentally make something up, but that's fine. And I've been doing that too, but then I thought maybe I shouldn't be skipping them, I don't know. So then I'm going to divide by h, so I have dh, or 1 over the square root of h times dh equals negative 1/10 dt. So now that I have them separated, what am I going to do next? Integrate, right? So I'm going to integrate both sides. So this is really the same thing as h to the negative 1/2 power, right? So when I integrate it, I add 1 to the exponent, so this gives me h to the 1/2 power. Then I divide by my new exponent. Dividing by 1/2 is the same as multiplying by 2. That's equal to, so this is just a constant, so this will be negative 1/10 times t, and then plus c. I would say go ahead and, we can go ahead and divide by 2 to get h by itself, or we could substitute it in here. What would you rather do? Find c now? That's totally fine. What you don't want to do is get all the way down to h and square it. That's when weird things happen. If you want to divide through by the 2 first, that's fine. If not, this is where, like, make a note to yourself where you're substituting this in. That way you know that that's where you're coming back to this version of it. So I'm going to have 2, and then this is t, this is h, right? So this is 2 times the square root of 5 equals negative 1/10 times 0 plus c. So that means c equals 2 square roots of 5. Okay, so now we're going to substitute this in here. So I'm going to have 2 times h to the 1/2 power equals negative 1/10 t plus 2 square roots of 5. Everybody with me? So we're going to have to divide by 2. When we divide by 2, we divide every single term by 2. It's the easiest way to do it. So this will give me h to the 1/2 power, or the square root of h. What is negative 1/10 divided by 2? Negative 1/20th t, and then those cancel out, plus the square root of 5. I still need to get h by itself. So what am I going to do? Square both sides. So when I square both sides, that's going to give me h equals negative 1/20th t plus the square root of 5, quantity squared. There is no plus or minus because we didn't take the square root anywhere. It's when you introduce the square root. And so that's where a problem comes in. Like if we'd have solved all the way for h here, we would have ended up squaring both sides and then getting our h. Then when we have to find c, we end up putting the square root in there, and then it just makes it kind of a nightmare. It's kind of why you don't want to go all the way down to the h if you don't have to. All right, good question. Anything else? All right. Let's move on then. Less likely to be able to actually break that pen because it's really just a stylus. Okay, still working with differential equations. We're going to look at some applications of this. Applications. With exponential growth and decay, which is something that is very important to you. I mean, that's a lot of real-world applications here with money and population and diseases and all kinds of things. So let me get to where I need to be here. Here we go. All right. So in many applications, the rate of change of the variable, so this is the important wording here. The rate of change of a variable y is proportional to the value of y. So the rate of change, dy dt, is proportional to the value of y. If y is a function of time, the proportion can be written as shown here. Okay? So it's not really written as a proportion. Y'all have done ratio and proportion forever. I don't know what the heck is going on with my board. But if you think about, if you have two triangles that are proportional, and you have these 3 sides, and then these 3 sides are different, but the triangles are proportional, can't you just take one set of sides, multiply them all by the same number, and you get the other set of sides, right? So it can be like I multiply everything by 2/3, or I multiply everything by 1/2, or whatever. That's your proportion, or your constant of proportion. That's what this k is right here. Okay, so the important thing, your rate of change is proportional. That's your constant, or your proportional constant to the value of y. Okay, y is a function. So we're going to solve this one to find the general solution. So I'm going to start by just rewriting this. dy dt is equal to k times y. Okay, k is a constant. I'm going to multiply both sides by dt. So dy equals k times y times dt. Remember, if you have a constant, it's a little easier to keep it on the x side or the t side or the independent variable. So I'm going to just divide by y. So I get 1 over y dy equals k dt. Okay, everybody with me? How do I have them separated? Yes. So now I can integrate. So when I integrate, how do I integrate 1 over y? Natural log of the absolute value of y, right? That's equal to k times what? T plus c, right? Because k is a constant. Everybody with me? Okay, so we're looking for the general solution, which means we have to solve for y all the way because we don't have anything to substitute in. So here's where I'm going to raise both of them to the e power, right? So e to the natural log, this is just going to give me the absolute value of y. That's equal to e to the kt times e to the c. Right? Just went ahead and split that because we've got to know how our exponents work. So then this is just plain old y because this becomes c times e to the kt. Now, yesterday, Miss Bruce left it as e to the c, which is fine. Sometimes she changes it to c sub 1. Sometimes she changes it to k. All of those, they're all fine. There are different ways of how you could see it. But also leaving it as c is perfectly fine also. And I think maybe that's probably like the simplest thing to do. Okay, but if you use something else, it's fine. You can't change it to k here like she did yesterday because there's already a k there. That doesn't work that way, right? But this is we've solved for y. This is our general solution. Okay? So if you talk about, so this is where it goes on to say, if y is a differentiable function such that this is dy dt because the rate of change is proportional to the value of y, then every time you integrate it, this is what you're going to get, what we just got, right? C is the initial value of y. Think about that. If the initial value, that means time is 0, okay? So if time is 0, let's just write this down. So the initial value means t equals 0. So that means that y is equal to c times e to the k times 0, right? I just put 0 in for t. That's all I did. See, all I did was substitute 0 in for t. That's it. Time is 0. K times 0 is 0, right? What's anything to the 0 power? What's e to the 0 power? 1. It's e to the 0 is 1. So that's why y equals c. That's your initial value, your y sub 0. It is c. That's your initial value, is c every time. K is the proportionality constant. That's the word I couldn't get out earlier. The proportionality constant. Exponential growth when k is greater than 0. Exponential decay occurs when k is less than 0. Okay? So let's see how we're going to use this. Well, it is. We have definitely done this type of thing when we have talked about exponential growth and decay before. You've probably done it in Algebra 2. We did it in pre-cal. We didn't talk about it like this, obviously, because it's a little bit different. But at the same time, we did have, I mean, these are some of your formulas for, you know, money and all kinds of stuff. The PERT formula. PERT's another way to look at it. P times e to the RT, because P is your principal. It's your initial amount. It's still your initial amount. It's just not the principal of, you know, the bank account or whatever. That's why it looks so familiar. Okay. So let's read these words. These words are important. The rate of change of y is proportional to y. It doesn't say y is proportional to y. It says the rate of change of y is proportional to y. And clearly we're using y and we're using t. Okay? So that means this. dy dt, that is the rate of change of y, is proportional, there's my k, times y. What this says right here is that if I separate and integrate and go through all that stuff we did up there, guess what we're going to get? We're going to get this right here. So that means I know that y is equal to c times e to the kt power. You with me on that? Yes. It's going to come up a lot. Okay, set. All right. When t, so what did they tell us what c is? It is a constant. It is the initial value. So what is it specifically for this question? 2. Because when t equals 0, y equals 2. That's your initial amount, right? Before we start, what did we start with? We started with 2. So that means that c equals 2. So y is equal to 2 times e to the kt. Now, eventually, I want to know what t of 3 is. But I don't know, I can't just substitute 3 in for t, because then I have this k and the y. I have 2 variables here still. Do I have enough information to figure out what k is? Yeah. Well, if I do this, I'm going to end up with 2. But they did give me this other set of information here. So I'm going to take this and substitute it in here. This is where that came from. Okay? So when I substitute this in here, my y is 4. So 4 is equal to 2 times e to the k, which I don't know, times t, which is 2. I got to solve for k, right? So I'm going to divide both sides by 2. So I get that 2 is equal to e to the 2k. Y'all okay with making that 2k? It makes a little bit more sense. How do I get a variable out of the numerator? The log. I'm going to take the natural log of both sides. So the natural log of 2 is going to equal 2k, because the natural log of e is 1, and that comes out in front. That's how we get it out there. I'm looking for k. So when I divide by 2, I'm going to get 1/2 times the natural log of 2 equals k. And then this is going to go in here. So I get y equals 2 times e to the k, which is 1/2 times the natural log of 2 times t. And that looks yucky, but that's okay. Right? So what I'm looking for, what is t equals 3? What is the value of y when t equals 3? So I need y of 3, basically. That's going to be equal to 2 times e to the 1/2 times the natural log of 2 times 3. At that point, you would punch it in your calculator. I chose for you not to get your calculators today just because we were going to take time on the other question, and we'll push buttons later. But what questions you got? Okay. All right, example 2 says the rate of change of v is proportional to v. The rate of change of v is proportional to v. And the variables I'm using are t and v. So the rate of change of v is going to be dv dt. It's proportional to v, so that's equal to k times v. When you integrate that, again, we could go through all those steps, but because it has this relationship, then we know that v is equal to e to the what? Oh, sorry. C. Oh, come on, board. C times e to the kt power. Do we know C? Yes, what is it? 20,000. This gives you C right here. Okay, so C equals 20,000. That means that V equals 20,000 e to the kt power. Now, do I have enough information to find k? Yes, because this is what's going to help me find k. So V is 12,500. That's equal to 20,000 times e to the kt power. So when I divide both sides, what did I do? Oh, 4. Yes, times 4. Thank you. All right, so when you divide, I was thinking ahead about what I was. This would be a calculator question anyway, so when you divide 12,500 by 20,000, you get 5/8. I'm just going to tell you that. That's equal to e to the 4k power. What do I do at this point? natural log of both sides. So I have the natural log of 5/8 equals 4 times k. So I'd rather this not be one big giant ugly fraction. So when I divide, I'm going to make that into 1/4 times the natural log of 5/8. That's equal to k. So then I'm going to find my actual formula here. So V, or V of t, we could write it either way, is equal to C, which is 20,000, times e to the k, which is 1/4, times the natural log of 5/8 times t. And it looks yucky, right? But that's okay, because it's going to be a calculator question. Just got to get all the pieces in the right place. So I want to know what happens when t equals 6. So V of 6 would equal 20,000 e to the 1/4 times the natural log of 5/8 times 6. And then the calculator would plop out a number for you. What questions you got? All right. I want you to read example 3. See if you can talk through it, get something set up, and maybe something worked out amongst yourselves. I know that it's multiple choice and there's decimals there, and yeah, I can give you a calculator, but just you can pretend like it's not a multiple choice question, because that's not going to really help you anyway. No, I mean, doubling means multiplying by 2. So every 10 years, there's twice as much as there was 10 years before. I just need to work it through with you. Okay. So we know dy dt is equal to k times y, right? And since that's a proportional relationship there, we know that y is equal to c times e to the kt. Okay, boom, right? All right, so k is a constant. T is measured in years. Population doubles every 10 years, and the value of k is blank. All right, so what we've been doing with the value of k is saying that the value of k is, well, I mean, we have to have something to substitute in, right? Our initial value, find c. Do we have an initial value? Nope. Okay. So when time equals 0, right? When time equals 0, then your y is equal to c. It's equal to the initial amount. Does that make sense? All right. So then when t equals 10, since it doubles every 10 years, then what would y equal? 2 times c. And this is a time where we actually do multiply 2 times c because we're not, like, we really want twice as much of c. Does that make sense to you? Okay, so if I go back up to here, and let's plug stuff in, like, well, let's plug in our initial amount. Okay, our initial amount is just c. Boom, it's right there, right? So now I'm going to substitute this stuff into here. So when t equals 10, y equals 2 times c. So instead of y, I'm going to have 2 times c. That's equal to c times e to the k times what? 10. Okay? Everybody with me so far? Because all we know is that it doubled, so we got that. So I need to get the e part by itself. What would I do? Divide by c. When I divide both sides by c, they just disappear. Mathematically, they don't disappear. They cancel out, but yes. They become 1. So then I have 2 equals e to the k, or 10k, right? Like a marathon. Then what do I do? Natural log. So natural log of 2 is equal to 10 times k. Then divide by 10, so k is equal to the net. Yeah. Like that. And that's what you would type in your calculator, and your answer would be A. I mean, I know you don't know that. You wouldn't know that that is A, like from that, but the calculator would tell you. But you have to get there before you start punching in your calculator. You don't, because it only asked me where, what is the value of k, since that's all it asked me for. I don't have to do anything else. Okay, we good? What questions you got? All right, I'll look at the next one. Read through it, discuss it. Oh my God. Right. Well, make this, instead of dx, make it t. I just realized that. So that would make sense. But I didn't type this. I know, and I did too the first time. I was like, why do I have an x? Well, because it talks about t all over it. That was just a mistake right there. Do we know c? 45. So do I write 45,000 out? No. The population of bacteria in a culture is given by a differential function where y of t is measured in thousands. So I don't write 45,000 like I did 20,000 up there. It's just 45. Okay? So that means here, y is equal to 45 times e to the kt. 4, Jesus. 45. I left off too many numbers. E to the kt. Because it says it's measured in thousands. So if I have 45, since it's measured in thousands, that is 45,000. I'll just know, yeah. Yes, exactly. Yes. Okay. So it increases according to this equation, okay, where k is a constant at time t equals 0, that's where I got this, and is increasing at a rate of 15,000 per day Find the expression for y of t. All right, so we only have a few more minutes left. I want you to think through this. I want you to actually try to finish this question before I see you on Monday, okay? The other thing is, I feel like we definitely need a lot more work with all these application problems, or the conceptual, but there are some just of the separating and rewriting that I kind of think that maybe you need some practice on. I'm going to give you this. I will put the key in Schoology. You don't have to do this, but you can do some or all of them. And I think it's just good practice on separating and rewriting so that different situations pop up. Okay? And if you want to get better at it, you have to practice.